Hi, welcome to the Circle Math differential equation problem solving section. All right, so today the problem we're going to solve is the sine square y plus x cotangent y dy dx equal to 1 and x to the pi over 4 equal to the 1/2. Okay, let's take a look at this problem. Let me tell you the way when I try to solve it at the beginning, I was trying to do the exact difference, the exact differences differential equation, and I tried the several methods, and it did not work. So I was wondering why it's not working then. So then I suddenly saw the initial condition. So let's say it's the function x is a function of the y. So they use the x, the initial condition, x to the pi over 4 equal to 1/2. That means when y equal to pi over 4, x equal to 1/2. So let's make me think, maybe I need to switch instead of the dy dx to the dx dy to change it to a functions, like x is a function of the y. And so maybe that's, easier. Also, if I also notice if I change the function of x is a function of the y, it turns out then the differential equation will be pretty good. See here, only the one x here is become linear. All right, so I think, let's give a try. So what I did here, I want to change, right? So the change to dx dy. All right, so now this is dy dx, so I can do the dx dy plus x cotan y will be dx dy, right? So I just multiply the dy, dx dy both sides here. All right, so after I do that, and then I can rewrite this. I will say this is dx dy and minus, right? So move this term minus x cotangent y equal to the sine square y. So it's very good. It's become a linear form. So this is the first order linear form of the dx dy. So we know if linear form of dx dy is easy, we can try to find the integration factor. So, okay, so here this is, I try to find the integration factors here. So here I would say du, now because the variable is y, so I need to say du dy, right, is equal to, so this is the, okay, so here, this is the, unlike the PT in the Bernoulli, so right? So now this one will be the negative cotangent y times u, right? Now, just like we did the dy dx, I need to solve for u. So I can move the du over here, and then here is a negative cotangent y, the dy's here. Okay, now I integrate both sides here. So, okay, so the integrate both sides. Okay, so integrate both sides here. Let me highlight the equation. I will need to substitute my integration factor back on later. So this is the one, right? So this is the one. Okay, so just highlight that. Okay, so I integrate both sides here. And then here, I will have a du over u equal to the negative cotangent y dy. So then this is the cotangent. I can set is a cosine y, sine y, dy, right? So then here we can do a simple u sub. Okay, so in here I can just say the u star equal to sine y then du star is equal to the cosine y here, right? So then this one will just be dy. So this term will just be 1 over u star and the du stars, right? Okay, so now this term, this one's here is ln u is equal to negative the ln. Here the u star is a sine y, so it's a sine y here, correct? All right, so now I can say the u is equal to the sine y here. Okay, oh, I'm sorry, this is negative, right? So here we have negative. So it's going to be 1 over sine y here. So 1 over sine y is equal to the cosecant y here. Okay, now what I need to do, multiply the integration factor back to the equation. Right, so that's the equation I highlight in the pink here, right? So let's say the cosecant y. Okay, so the dx dy minus, okay, minus x cosecant y cotangent y, okay, and is equal to cosecant y sine square y, okay. Then my right hand side cosecant and the sine is the inverse, not inverse, is a reciprocal function of each other, right? So cosecant and sine, so the right hand side, the right hand side will change to be a sine y. Then because this is the integration factor, so the left hand side, you know, like we always do it, we can change this to kind of like the what, kind of like the product rules, right? So in here, this is dx dy. So let's rewrite this once here. Okay, so here this will be, so will be the x cosecant y here, right? So it's the product rule if you see here. So if you take the derivative of x, it's going to be dx dy cosecant y. Then you take the derivative of y here. So it's cosecant cotangent, right? So it's the derivative of the cosecant y. So it's negative. So we know that's fine. Okay, now you integrate both sides. Okay, so when you integrate both sides, because this is the product rule, so your left-hand side going to be x cosecant y and sine y, right? So your integrate are going to be what is negative cosine y plus c here. Okay, so now we can substitute my initial condition. My initial conditions here is x pi over 4 equal to 1/2 here. So remember, right? So this is the change. So that means this is my x value and this is my y values here, right? Okay, now let's substitute to my equation. So this is 1/2 cosecant pi over 4 is equal to the negative cosine pi over 4 and the plus c. So the sine pi over 4 is the square root of the 2 over 2, but the cosecant is the reciprocal. So this will be 1/2 times the square root of the 2, right? So then the cosine will be the negative square root of 2 over 2 because it's negative sign plus c. All right, so the c is going to be the square root of the 2 over 2 plus the square root of the 2 over 2. So it's the square root of the 2. So finally, my equation will be x cosecant y equal negative cosine y plus square root of the 2 here. Okay, so that will be my the final answers here. Of course, you can try to change to x equal to divided by the cosecant on both sides. You can do that, or you can just leave like this. That would be fine here. All right. All right, that's it. And I hope this helped. This is a very interesting problem. And if I did not notice the initial condition, maybe I still struggle with some other methods here. All right, that's it. Okay, so nice to talk to you again. So looking forward to talk to you for our next province here. All right, bye. Have a good day.